We present UniteXR, a cross-platform smartphone AR and VR system that enables an on-site user and remote user to simultaneously co-navigate and explore a physical space and its digital twin. To fuse the physical space with the digital twin, we use Microsoft Azure spatial anchors to create cloud anchors. Each anchor has transform information with respect to the physical space that could be recovered later on during runtime. These anchors also have a virtual counterpart in the digital twin. This helps us to calibrate the digital twin's pose and accurately overlay it in the real world. Our approach further helps during recalibration in case an offset occurred due to the smartphone's loss of tracking and to mitigate drift. As the observed physical space grows in surface area, the challenge to identify and find other users in the space increases. This becomes more challenging to AR users when they are following a VR user that uses common VR navigation techniques such as teleporting. Therefore, we design and implement two different awareness visualization methods to support the AR user in knowing the distance, path, and location of the VR user. In a pilot study, we asked 20 participants to locate and navigate to a teleporting and a moving simulated VR user. We further compare both visualizations and measure the duration required for the AR user to locate the teleporting and a moving simulated VR user. Our results suggest that participants easily located and followed the VR user while using either of our visualization methods. To further enable communication between the different users, we create a gesture-based and text-based communication approach for the smartphone AR user. Through a set of buttons, AR users can create waving, beckoning, and pointing gestures to communicate with the other users. We evaluate our system in a real-world scenario of museum co-exploration between an on-site smartphone AR user and a remote VR user. We invited experts from the museum to test our application. They were asked to navigate around the museum as well as point towards different artifacts and communicate with each other. Our findings suggest that UniteXR allowed for easy navigation and communication between hybrid participants in a museum co-exploration scenario. Overall, UniteXR improves awareness and interactions between an on-site smartphone AR and a remote VR user.